Hey everyone, and welcome back to the channel. The urgent question. Imagine a world where your online security, your bank accounts, even national defenses crumble overnight. It sounds like science fiction, but by 2030, this could be our reality, all thanks to a technological marvel we're barely beginning to understand. Are we sleepwalking into the ultimate cyber catastrophe? The silent dawn, cracking the digital fortress. Imagine every secret, every secure system laid bare. That's the whispered fear as quantum computing accelerates. For decades, our digital world has been protected by an invisible shield: encryption. Complex mathematical problems that would take even the most powerful supercomputers billions of years to solve. But what if there was a machine that could solve them in minutes, or even seconds? This is the promise and the peril of quantum computing. Unlike classical computers that store information as bits, either a 0 or a 1, quantum computers use qubits, which can be both 0 and 1 simultaneously. This bizarre quantum phenomenon, called superposition, allows them to process vast amounts of information in parallel, unlocking computational power previously unimaginable. The quantum threat to encryption, specifically certain quantum algorithms, like Shor's algorithm, pose a direct and devastating threat to the very cryptographic standards that underpin almost all modern security. We're talking about RSA and ECC, the algorithms protecting your online banking, your emails, your VPNs, even the secure communications of governments and militaries. For example, breaking a 2048-bit RSA key using a classical computer would literally take longer than the age of the universe. A sufficiently powerful quantum computer, however, could do it in mere hours, perhaps even minutes. This isn't theoretical. It's a matter of engineering and scale. The precipice of 2030. So why 2030? While we don't have a fault-tolerant, large-scale quantum computer capable of breaking current encryption today, the pace of innovation is staggering. Major tech giants and national labs are pouring billions into this field. Experts estimate that within the next decade, we could reach the tipping point, a state often referred to as quantum supremacy or quantum advantage for cryptographic tasks. This isn't some distant science fiction movie. This is the timeline we are on, and the implications are terrifying. The impact, Cybergeddon scenarios. What would a Cybergeddon actually look like? First, imagine the immediate compromise of all encrypted data that has been harvested now, decrypt later. Nation-states and sophisticated criminal groups are already collecting vast quantities of encrypted information, knowing that someday they might have the key. Then, consider the real-time threats. Financial systems collapsing as transactions can be spoofed or reversed. Critical infrastructure, power grids, water treatment plants, vulnerable to unprecedented attacks. Secure communications, from military intelligence to corporate secrets, instantly readable. Our entire digital trust framework would disintegrate. What is post-quantum cryptography, PQC? So is all hope lost? Not entirely. The cybersecurity community is not standing still. The race is on to develop post-quantum cryptography, or PQC. These are new cryptographic algorithms designed to be resistant to attacks from even the most powerful quantum computers. Organizations like NIST, National Institute of Standards and Technology, have been actively evaluating and standardizing several promising PQC algorithms. These new methods rely on different mathematical problems, which are believed to be hard for both classical and quantum computers to solve. The migration challenge, a titanic task. However, simply developing PQC isn't enough. The real challenge lies in migrating our entire global digital infrastructure to these new standards. Think about every device, every server, every application, every protocol that relies on current encryption, from your smartphone to massive cloud data centers. The scale of this transition is monumental. It's not just about updating software. It often involves hardware changes, years of testing, and coordinating across countless organizations, industries, and nations. And this migration needs to happen before the quantum computers capable of breaking current crypto become a reality. Why the urgency? The crypto-agile imperative. This brings us to the urgent question: why aren't we moving faster? The concept of crypto-agility is critical here. It means designing systems that can easily switch out cryptographic algorithms as new threats emerge or new standards are adopted. Unfortunately, many legacy systems are crypto-brittle, hardwired with old algorithms, making updates incredibly difficult and expensive. The longer we wait, the larger the target grows, and the more complex the eventual transition becomes. It's not just a technical problem. It's a policy, economic, and strategic challenge, geopolitical ramifications, and the arms race. Beyond individual security, quantum computing presents a terrifying geopolitical arms race. The nation or entity that first achieves cryptographically relevant quantum computing could gain an unprecedented intelligence advantage, compromising the secrets of adversaries and allies alike. This could fundamentally shift the global balance of power. Imagine the impact on espionage, military communications, and economic competition. The incentive to develop this technology and to develop countermeasures is immense, creating a complex and potentially destabilizing environment. The role of individuals and organizations. So what can we do? For individuals, while the immediate threat isn't directly at your doorstep today, understanding the landscape is crucial. Support organizations pushing for PQC. Be aware of the data you share, and understand that anything encrypted now could be decrypted later. For organizations, particularly those handling sensitive data, the time to start planning your PQC migration is now. Conduct inventory of your cryptographic assets, understand dependencies, and begin budgeting for this transition. Ignoring it is not an option. The dawn of a new digital age and hope. It's not all doom and gloom. Quantum computing also holds incredible promise for advancements in medicine, materials science, artificial intelligence, and even new forms of cybersecurity. This isn't just about threats. It's about navigating a paradigm shift. The move to PQC, while challenging, will ultimately create a more robust and resilient digital infrastructure. It forces us to reevaluate and strengthen our security posture, preparing us not just for quantum threats, but for future unknown challenges. Call to action and final thoughts. The Cybergeddon of 2030 isn't inevitable, but it is a very real possibility if we fail to act decisively. The silent dawn of quantum computing is already here, and the race to secure our digital future is on. This isn't just a technical problem for engineers. It's a societal challenge that demands urgent attention from policymakers, businesses, and every individual who relies on digital security. What do you think? Are we doing enough to prepare? Let us know your thoughts in the comments below. And if you found this video insightful, please hit that like button and subscribe for more discussions on the future of technology and security. Don't forget to like, share, subscribe, and comment. Your support helps us make such content.